طيب, Bismillahirrahmanirrahim. So last time we started talking very high level about the multimedia applications. We categorized multimedia applications into real time and non-real time. We talked about diverse set of multimedia applications, and we have talked about the level of guarantees and the immediate deadlines that we need to, in some cases, set on a specific application to deliver the multimedia content. We started talking about different applications, different multimedia applications, starting with peer-to-peer, which we have discussed that it's broad in the sense that it's not only used for sharing files, but it could be used for sharing anything, whether this is like sharing memory, sharing computations, or even sharing energy in some cases. So these are some of the frameworks that are used for sharing files. Of course, other technologies are not yet standardized, like power exchange and over wireless and so on and so forth. These have not been standardized yet. Another application which uses different wireless technologies, whether it's satellite communication or maybe 4G or 5G, is telemedicine. And in telemedicine, the multimedia content that we're talking about are human vital signs. So human vital signs like person's temperature, person's EEG, like brain signal, or ECG, heart signals, and things like that. And we need to deliver these vital signs through specific wireless technologies to a center where a physician is sitting on the other side, and he's trying to use this data for diagnosis. Okay, so whether this is used for telemedicine in remote areas, where in that case you need to use very long range communication like satellite communication or cellular communication, and or whether this is on a short range type of communication where you need to a physician needs to walk over the hospital and be able to access the patient information from anywhere in the hospital, while the patient could be in any room in the hospital, in which case, again, the wireless technology that we need in that case would have like a medium range, like Wi-Fi or something like this, or maybe on the personal access network level. That's on the wireless technology level. On the multimedia content itself, there are again variations of guarantees and deadlines that we can set on delivering this multimedia content, and that depends heavily on the type of application that we are talking about. Whether here we're trying to help a person who has a seizure, in which case it's an immediate thing and it's a life-threatening application, in which case the multimedia content has to be delivered very, very fast. So we need to have delay guarantees on delivering this multimedia content, or maybe it could be used for normal daily diagnosis offline, in which case we just need to deliver the information, but we don't care about any delay guarantees in that case. Okay, so there is some constraints that the application enforces on us, and based on that actually triggers the use of a specific wireless technology and a specific quality of service on how to deliver this multimedia content from one location to another. Another type of application, which is voice or video telephony, using voice over IP or video over IP. And thanks to this type of technology that we have now, Cisco phones all over the place in QU, which we use it for communication. Of course, in the past, ITS or any service provider could have not deployed this type of service if it wasn't for the issues that we'll study in this course about how to provide some guarantees for multimedia applications to provide this type of service. So in that case, the QU network needs to have some discrimination and some distinction between the different types of traffic, whether this is a student who's browsing the internet or this is a voice call. And all this type of information is now being transferred over the same network, right? So you as a student, you get some quality of service which fits your application. So you can download any content from the internet and you can wait for a few seconds to get this content, which is not a problem for you. But at the same time, voice over IP, this is a type of traffic that's real time, and in that case, we have to provide some delay guarantees. So our network should be intelligent enough, okay, to distinguish between these different types of traffic and provide the guarantees for this diverse set of traffic over the same type of network. So in that case, we get, nowadays they talk about network convergence, where the same type of network can now provide diverse set of services on the same network, and that concept did not exist in the past. So in the past, we had public switch telephone network, which is used only for voice calls. We never used it for data, and we never thought about using it for data. But now we have cellular network, and we could have data plans, and we could have video at home where we can watch video on the same network, on the same Ooredoo network, and we can have some voice calls on the same Ooredoo network. We can have data transfer on the same Ooredoo network. So this concept is really revolutionary in the sense that you can have very diverse set of applications on the same type of network. Okay. So these type of gateways, these are used to give us this quality of service. It needs to interact with the routers of the network inside QU to provide the type of quality of service that we need. So they need to do this distinction. So this gateway will actually separate between the voice traffic and the normal traffic, and will give both types of traffic to the router, and then the router will schedule each traffic differently based on the quality of service that we need for this type of traffic. Okay? This public switch telephone network is the legacy type of network that we use only for voice calls. Okay? So this is a special type network. It's not a converged type network where it provides all these services on the same network. No, this is used only for voice calls. And there is some types of network which is only used for data. Like, for example, Wi-Fi. Originally, Wi-Fi was mainly used for data transfer, and it was never meant to be used for voice calls until maybe 1 or 2 decades back, when people started to talk about using Wi-Fi for even voice calls, and they came up with voice over IP, and we'll study this standard as part of this course, which is 802.11e, which provides some quality of service guarantees for multimedia applications. Another type of applications that's used for short range connectivity on wide range of devices. So on a personal area network, you could have your cell phone communicating to your headset, communicating to a printer in your proximity in a very short range. And again, you have different devices with different requirements or different diverse set of traffic. So you have a cell phone, which can be used for voice and for data. You have headsets, which are used mainly for voice. You have printers, which are used for text printing and image printing and stuff like that. So each type of device uses content in a different way, and your personal area network should be able to, again, distinguish between these different types of traffic. And this is a very challenging job, as we will see as part of this course. Okay? So an example of this short-range standards is Bluetooth and Zigbee, of course. Bluetooth is the predominant by all means. because it's deployed in all devices now. Okay, Zigbee is mainly used for industrial applications, and it's not as widely deployed as Bluetooth. So we covered satellite communication, we covered Wi-Fi, voice over IP, we covered personal area networks, and this is cellular. For cellular, we also have historically started from mid-90s when they came up with the Global System for Mobile Standards, or GSM. So all the technologies, all the cellular technologies that we have nowadays are built on top of GSM. Okay? So all the 4G and inshallah 5G in the future, and 3G, and all of this is built over GSM. So GSM talks about or standardizes the way that we communicate voice over a cellular network. Okay, over cellular network. The standards started in mid-90s, and as part of the standard, there is some component, very important component that we use on a daily basis, which is SMS. Okay. One thing about SMS is that SMS itself, even though it's used for text exchange, okay, which is data exchange, but it doesn't require any data plans. Have you noticed this? Is that even if you have no data plan, you still send and receive SMS, right? So have you ever asked yourself why? Even though this is data service essentially, right? It's not voice, right? But it doesn't require any data plan. So why do you think this is the reason? So
the transmission of it is different. The transmission rate.
the data plans are used to trigger the network that there is some data that's being exchanged for this user other than the voice, right? For SMS, even though you are trying to send text, but you don't need to have any data plans for this. The fact of the matter is SMS is actually built inside a GSM without the need for any data exchange. What happens is that GSM itself uses different channels to move the voice from one location to another. So our voice gets sampled, so we know the sampling theory. Our voice gets sampled, and these samples, they get sent over GSM, right? The fact that the cellular network provides very high quality of voice, we will talk about it in the next slide, because this requires the concept of circuit switching. So it provides virtual pipes for voice to go straight ahead without any blocking or anything, and that's why the voice quality for GSM is very high, as opposed to if we use any data plan, or if we use Skype, for example. Sometimes the voice is very distorted, right? Because the quality of service guarantees for Skype is not as strict as the circuit switching guarantees that's provided by GSM. But SMS is actually, it doesn't require this type of quality of service, and that's why it's built into GSM, that while GSM is sending, so if we were to, so this is your phone, okay, and this is the network, and this is the server inside the network. So your voice gets sent in virtual pipes. These channels are called voice channels. So your voice call uses one or more of these voice channels. Okay? But there is what we call a control channel. Okay? The control channel is used mainly for signaling. like when you establish a call, the first thing is that you need to transfer your phone number, right, to the cellular network so that the network can authenticate that your phone can establish a call using your phone number and so on and so forth, right? And then the control channel can establish the voice channel, which carries your voice to the other user, right? So this control channel is used to send control information. So the intelligent thing about SMS is that it actually sends the text over this control channel. So it sends it as if it sends your phone number. Okay? So it's sort of hacking, or sort of it tries to use the control channel for something that it's not originally used for. So it sends the text over this control channel. Okay? So this does not require any specific data plan, because data plans are established using some data channels, which did not exist in the early days of GSM. In GSM, there was no data channels at all. Okay? So the control channel is used to establish voice channels or data channels based on the need of the user. Okay? So SMS gets its way through the control channel without having to establish any voice channels or data channels. That's why in the early days of SMS, there was a constraint on the number of characters. If you notice here, the number of characters on the message did not exceed 160 characters, right? So even nowadays we have this on Twitter. On Twitter you have some limitation. Right? So that was a constraint because of the fact that we're using the control channel, which is used to send commands and small signals. So we sent only this amount of text. But later on there was another extension of this standard called enhanced messaging service. So the EMS, it's actually a transition phase between SMS and MMS. There was like some phase in between, which we did not really use that much. By the time we started to use MMS started to be released, and we started to use, and MMS stands for Multimedia Service or Multimedia Messaging Service. So EMS was standardized in 2000, and as part of this, the limitation of the 160 characters got relaxed a little bit, so we started to be able to send not only characters, but some very low resolution pictures. Again, over the control channels. And that's the good thing about it, is that it does not require any extra data channels to be used in that case. Okay? Starting from MMS, by the time MMS was released, MMS was released together with the 2.5G. So GSM itself is second generation. Okay. So the 2.5G was the first generation where they started to introduce some data service, very, very low rate data service together with the voice service. So originally, the cellular network was originally designed for voice calls. So the first service that they provided over using mobile phones was a voice, right? So starting from 2.5G, they started to introduce the concept of data channels, okay? And with that, we were able to send very low data rates over cellular networks using our mobile phones. And of course, that opened the door for some services. One of them is multimedia messaging service, in which we can use some video, some small clips of video, and some pictures and stuff, and exchange this over messaging service, right? Of course, WhatsApp now uses similar concept, okay? But it uses data service for sure, okay? So the only service that it does not require any data plans is a SMS, right? So that's why even if you have the very old Nokia phone with no data plans at all, you're still able to send SMS, right? Because of this hacking in GSM standards, where they use the control channel, and the control channel is the minimum. It's a requirement. You have to have the control channel, and from this control channel, you get to create either voice channels or data channels. Okay. مفهوم كده؟ So any question in that regard? So that's like a small evolution of some of the multimedia type of applications over cellular networks. So we talked about an example for satellite communication. We talked about an example for Wi-Fi or voice over IP and video over IP. And we talked about wireless personal area network, and this is for cellular network.
In case the satellite communication, anyone can establish a communication or only special people?
No, again, I mean, in satellite communication, you need to have a service provider in the picture. So you have, well, some service providers, even Ooredoo, as far as I know, at least they used to provide the service through satellite communication. You just need to rent some bandwidth from one of the satellite providers out there, whether it's Sat or, and so I know that they provide this service nowadays, but they mainly use it sometimes maybe for MOI, for Ministry of Interior, or maybe for the military and things like this. So there is a special type of service they provide to certain types of users, not to consumers like ourselves anymore. But actually in the past, they used to provide internet through satellite. So I know that. But this stopped because for most of this type of satellite communication, it goes through like very large delays because of course the signal has to go all the way up and down. So there is some limitation on the data rates that you can get with this type of service. But of course they still use it to reach to very far areas, remote areas, and also because it's more secure and private. It's not public like the Wi-Fi and these kind of things. It's not public, so they can secure it easily. Any other questions? This is like an example of a multimedia application protocol. Okay, this is the application level protocol. We're not talking about wireless technology here, although it's called wireless application protocol because of the fact that it works on wireless phones, or this type of standards, it actually works on mobile phones. And basically what it does is that it emulates a browser, but with a very stripped down functionality to be able to work on mobile phones. Not the mobile phones that we have nowadays, because on smart devices that we have nowadays, we can run like a normal browser and things like that. But here we're talking about the old phones. Old type phones with a very small screen. They require special type of application level standards to be able to exchange information, because of course the amount of information that you can display on this small screen is very tiny. Okay, it's very limited. So you need to have more frequent communication with the server to be able to download different types of information. So at the beginning, they have standardized what we call wireless application protocol version 1, and then starting from version 2 here, they started to integrate WAP with HTTP. And that was the beginning of what we see nowadays, that we have a normal browser running on a cell phone, and it can give us very close, amount of information similar to what we have on a tablet or on a normal laptop. So with this, you can exchange rich amount of information, whether it's multimedia video, audio, and graphics, and text, and so on a bigger screen type of devices, like the smartphones that we have, or maybe a tablet, or even a laptop. Another thing that WAP uses a pull model versus WAP 2 uses a push model. What is the difference? So pull model, it always works based on request and response, which means that you request to get an information, and then you download this information to your device in order to display it on the screen. A push model talks about the fact that it's one way. You push information to a specific device, and then this device will initiate some type of a notification that there is this information on the server, and somebody can look at it. So pull model is always based on request and response type of model, versus the push model is based on notification. So as if you remember in 455, okay, we talked about HTTP, and we said that for HTTP we have a command called get. So get uses some kind of a pull model where you send a command and then you get a response for this command. Whereas there is a command called push, okay? So in which case you do not expect any response from the server, but you push information to the server, and the server will just process something, and then this is used for sometimes if you want to finalize a transaction, you send all the information to the server, and the server processes it, and then it gives you yes or no. That's it. Okay, but you are not expecting any information back from the server. Okay. All right. So any questions so far? So this is basically the summary of chapter 1. Again, in this chapter we talked about the definition, the basic definition of multimedia application and multimedia communication. And we categorized the multimedia applications into real-time and non-real-time. And then we covered a range of these types of multimedia applications and the need for different quality of service for these different types of applications. That ranges from very harsh and very hard deadlines to very loose or no deadlines at all, which means that we get the best of what the internet can provide us, but we don't actually need something immediately. So we can tolerate some delays or in some cases, some loss. So in this chapter, we need to try to define what this quality of service really looks like, and how do we quantify it? How can we quantify this quality of service? Okay, we need to work on what levels do we have in order to say that this is a real-time application, this is a non-real-time application. How much is the deadlines that we need, and whether we have like some discrete levels or some continuous levels, and so on and so forth. So, and of course, comes with that is that what do I need in the network in order to provide this type of guarantees? So we need to understand some terminology and some schemes, like multimedia delivery schemes. And there's nothing new here. We're talking about unicast, multicast, and these kind of things, which we're all familiar with. Then we'll talk about dynamic versus static channels. So dynamic channels are the channels that have variable type of bandwidth, and it changes. So what causes this channel to change? And why do we need to classify them in this way? Is because, of course, dynamic channels are very much challenging in providing quality of service. Because if you have something that varies, how can you guarantee something that you're not really aware of? you're not aware of these changes, yet you need to provide some guarantees. So how do you do this? So that's what we need to talk about. From the network point of view, we have packet switching versus circuit switching. And we need to talk about that here. Of course, we talked about it in 455, I hope. But we need to talk about it here again because it does affect how we provide guarantees to the traffic. Because on circuit switching, as we will see, it's very easy. It's not challenging. On circuit switching, it's very easy to provide quality of service guarantees because circuit switching provides, in a way, static channels. Okay? In a way, it provides, to some extent, it can allow your channel to be static or dynamic, but not in a wide range, in which case providing quality of service guarantees will be easy. Versus packet switching, it's dynamic, but it's very efficient. Okay? So it can give us a wide range of efficiency, but it's challenging to provide quality of service. So how do we address that compromise or that trade-off? So from that, we can quantify and talk about a specific quality of service support. How do we quantify this quality of service support? Which it can be defined based on variable bitrate or fixed bitrate. So we'll talk about what is the difference between constant bitrate and variable bitrate, and what does it entail in terms of, again, quality of service guarantees. Okay? So, of course, we're all familiar with this first aspect of the chapter. So, multimedia delivery schemes. We know that unicast talks about the transfer of information from one node to another node. So, the source is one node and the destination is one node. So basically, any type of voice or video call between two people requires the establishment of a unicast channel, okay, which is used for bidirectional communication from one point to another. Usually that has like some back channel, and the back channel could be used for the communication on the other side, or at least it has to be used for giving some feedback that whatever I'm sending is actually reaching on the other side, which is what we call the acknowledgement. So remember we talked about acknowledgement in 455. There is some type of channels which is without back channel, and in that case the sender has limited knowledge about the channel, which is similar to sending a letter in the mail. So the person on the other side is not expecting the mail to arrive, and there is no way through the mail system that this person can acknowledge that he actually received, unless you use a special type of mail service which requires some notification from the other person that he or she has received that letter. Okay, so both types of communication run on a unicast channel, where the communication is always between one person and another, or one device and another. For broadcast, you have the source as one node, but the destination is all. Okay, so it's like me talking to the class now. So it's the source is one and the destination is all. There's no distinction between any node in the network. So if the source sends anything, all the nodes on the network will listen to it. And of course, a perfect example of this is what we have studied in 455 for multi-access networks, where we have a logical bus, and any one of the nodes sends anything on the bus, everybody else will listen to it. Okay, so I cannot force some nodes not to listen to that signal because it's broadcast. Feedback in the type of multicast, of course, is again a subset of the nodes. So when I talk, I need only subset of people to listen to my talk. So always for broadcast and multicast, the feedback channel is very challenging. One of the one of the challenges for these types of delivery schemes is that the feedback is very challenging, because when the source sends some information to all the destinations, how can I figure out that it has reached to all destinations? Okay, so for unicast, I just need to wait for the feedback from the destination, acknowledgement that it has received it, and that's it. So I move to the next. But here, how much should I wait? Okay, it's a challenge. So should I wait to get acknowledgement from all of them? Then good luck, you'll wait forever, right? And also, this node will have to process the feedback from tons of nodes, which is a big overhead. Okay, so typically, broadcast and multicast are sent over what they call unreliable channel. So I push the information to all the users, but usually I don't have to wait for acknowledgement from all the users, otherwise I'll wait forever. So I'm push, and then I pray that it will arrive to the other end. بدأ كده يعني ربنا يسهلها وتوصل. So typically that's the scenario, because we cannot afford really waiting forever for all the nodes to reply back. This is really one of the challenges for these types of delivery. Okay, Anycast is a specific type of delivery which I have group of nodes, okay, and I can select any one of them. For example, I want to print a document. I don't care which printer I use. Okay, I have an Anycast session to all the network printers, okay, in this building, and I don't care which printer is used. I don't care. I just need my document to be printed. So I push. I send this information to the router without having to specify any IP address. Okay, and the router will select the printer based on any criteria. It could be based on this printer is closest to you. Maybe this printer is not working, so I'll try some other printer. I don't care. As a user, I don't care. As long as my document gets printed, I don't really care. So this is what they call a Anycast. So it's not multicast, not broadcast, right? It's called Anycast. So I have group of nodes. I have the session to all of them. I have the session itself defines all the nodes. But when I send, I need to send to any one of them. Okay? فهمنا فرق? Any questions? Okay. So the dynamic channel versus static channels. Most of the communication involve channels that characteristics vary with time. يعني, especially when we talk about wireless, the channel itself has no fixed bandwidth, right? So for wireless signal gets transferred over the air, right? So if somebody is actually walking by, this person will affect the wireless signal, and that's why maybe one of the senior projects is actually to use this characteristic to localize people in the room, or to maybe count the number of people in the room, or something like this, right? Why? Because of the notion that human beings or any obstacle, like tables and stuff, they affect the wireless channel. So this characteristic of the wireless signal, okay, causes the bandwidth or the capacity of the wireless signal to vary. Whether you accept it or not, that's the case. So even in a room with fixed objects, sometimes the bandwidth varies a little bit. But if someone is walking by even outside, he or she will affect the bandwidth of the channel. So in that case, the capacity of the channel varies over time. The capacity is what? Is how much information the channel can carry over a unit time. This is the bandwidth, basically. Okay? Or the error rate. The error rate, because if a person again is walking by, he may actually deform or block the wireless signal, in which case the information that I'm sending at this point in time there is a high probability of error in that case, okay, because the signal itself gets affected. So the error, of course, if I use a reliable transfer protocol like TCP, okay, in that case there is no error, but in that case the delay will be affected, because even if I get some packet drops, I have to try again, right? So when I try again and again and again, I will get delayed, right? So this dynamic channel could cause the capacity to vary, cause the error or the delay to vary. So 1 unit of information I could send using 3 trials or 4 trials. One unit of information could go through in the first trial, so you never know. So in that case, the error rate is different throughout the time, the delay is different throughout the time. So the channel looks like this. This is the bandwidth, okay? So the question is, when I provide some guarantees, I need some deterministic type of performance so that I can say, I guarantee for you this amount of information per unit time. This is what Ooredoo does. It gives us the plan based on, you have 10 megabits per second, right? You have this and that. But these are not hard guarantees. I mean, if you try to measure the actual data rates that you get over the day, you say that it goes up and down, right? They cannot guarantee this. So this type of dynamic channel is very challenging in terms of providing some guarantees to the user. But we can improve that. Of course, Ooredoo is not really keen on individual users. They are keen more on big customers, okay? So they can provide these type of hard or deterministic guarantees to big customers as opposed to users. So there is some type of mechanisms that can provide some guarantees, not 100%. It can almost never guarantee 100% the performance to anyone, okay? But at least you can improve that. You can give like some 90% chances that you will get this amount of rate consistently, okay? So you can provide some guarantees, but not 100%. So video communication over dynamic channel is very much difficult. Very much difficult. But with the proper mechanisms in place, we can make this happen, and that's what we have nowadays. We can have very good video communication over different types of network, whether it's wireless or wired. So examples largely of static channels are DVD, of course, that we have. But DVD is not, well, it's local drives and it's deterministic. So it's not over a long range of communication. But what would be a good example of dynamic channels is the wireless or the internet. The internet being dynamic because of you don't have any idea how many users are accessing the internet at any point in time, right? So in that case, it's dynamic because at one point throughout the day, I'm using the connection to Ooredoo, and it looks like I'm the only one using this connection. So in that case, I can get very high data rates. But we can see that during afternoon hours and stuff, everybody is bombarding the internet with traffic. So in which case, your share of the traffic will go down. So even on wire, you have very high chance of having a dynamic channel as well, even on wire. So it's not necessarily the case that when you have wired network that your channel will be static. No, not all the time, not necessarily. Okay? But wireless intrinsically is dynamic. Okay? So we'll talk about the next time.